exactly at the same spot. Can you do me a favor? I'm going to give you like 4 minutes to graph out tangent. Do we remember tangent? Okay, 4 minutes. You and your peeps. I want you to go like a pi to the right and a pi to the left. Okay. So your team, you and your team, go a pi to the right and pi to the left for tangent. Do we remember tangent? If you don't, it's okay. Talk it out. Hey, I remember this part. You remember that part. Let's put them together.
I know it looks like.
Yeah. So it reaches its it hits one.
No, it's
right?
yeah.
Or
The
five.
Huh? That's for you and your team to discuss.
I know the period is 5, and the period is like here. So I guess it's not. I remember it like doing this, parabolas, and then you connect it.
I think that's the ground. Yeah, that's the ground.
But like I don't even know. Yeah, looks like that.
If you don't remember, make a table. Make a table. Okay.
But pi can be approximate.
I was like, wait a minute. This isn't no, that's right. I was like, wait a minute. This isn't.
Should tangent be parabolas? No. Okay. No parabolas. Almost like a cubic-ish, yes. That's right.
I do this right.
5/4. Okay, it looks good, but how come some are fatter than the others?
Because I like weird stuff.
You labeled it.
Yeah, I wasn't thinking this was like
Are the labeling? Oh, is the spacing different? Is that why?
Yeah,
One?
that's
Okay.
why.
Okay.
So like,
Got it. Because I was like, some are fatter than others. Okay, what's tangent at 0? 0. Do you remember why, by the way? Here's at 0 in the unit circle. At 0, cosine is what, by the way? 1. Sine is 0. So tangent is always what divided by what? Sine divided by cosine. So it's definitely 0. Okay. How about pi over 4? 1. I love pi over 4. All right. And then pi over 2? Undefined. Then we're going to go to pi. 0. Okay. Because I also asked you to do something on the negative side, I'll just make the table for that. Negative pi over 4. Yeah, negative pi over 4. Negative 1. Negative pi over 2. Undefined. Negative 3 pi over 4. 0. And back at negative pi is also negative pi over 4 is 1. I'm sorry. And then 0. Thank you. All right, let's plot the dots. 0, 0. Pi over 4 shoot up at 1, pi over 2, asymptote. And then we have 3 pi over 4, that's negative 1, right? Do you have 3 pi over 4 written? Where is my, oh, this is supposed to be, I missed 3 pi over 4, didn't I?
Yeah.
All right, let's insert 3 pi over 4 should be negative 1 right there. Then I'm going to, at pi, I'm going to say it's 0. Negative side, negative pi over 4, it's going to be negative 1. Asymptote again. Negative 3 pi over 4, go up at 1, and then we are now back to 0. Okay, so I did see lots and lots of good graphs. Okay, that's one of it. This one, even though I only have 2 dots, but feel free to like go up to kind of finish it up. Same thing with this one. I only have 2 dots, but feel free to go down just to sort of finish up the curvature. Is this tangent graph a 1-to-1? No. Okay, because you said no. We have to restrict, so it can be a 1-to-1. Okay. If you're in this meeting with a bunch of mathematicians, what would you say? What would you restrict? Very good. Inclusive and not inclusive? Right. Okay, they're undefined at these 2 endpoints, okay? Then let's define our definition. Just like yesterday, what would you start writing? X equals tangent of y. Box it up, call it a day, take a nap. No? How would you solve for y? Y equals f inverse of x equals what? Tangent inverse of x. Is it okay to call it arctangent? It's really up to you. Again, our book uses the -1 notation, but other books, like last year's book maybe, what did they use last year? Both? Okay. Let's define the domain of tangent inverse. What is the domain of tangent inverse? All real numbers, is that right? Yes, because the range of the regular is all real numbers. What is the range of tangent inverse? That's right. All right. That's right. Very good. I'm also going to mention the quadrants. Because remember, just like what we just finished up, sometimes I'm going to say, well, tangent inverse is restricted in quads so-and-so. So what are the quads so-and-so? What quadrants?
Second and the fourth.
Is it second and fourth? No? Okay, let's go back to the unit circle. Negative pi over 2 is right here, right, class? What quadrant is that? 4?
Oh, you mean the first and fourth?
Ah, pi over 2 is right here, right? So what 2 quadrants are we talking about? 1 and 4. Okay, which is really similar to one of the ones we did yesterday. Which one is that? Sine inverse as well, except sine is inclusive and tangent isn't. Okay, we are going to graph out the original piece first. So here we go. I'm going to do a different color. I'm going to go as far out as looks like pi over 2. Okay, so here's negative pi over 2. Go up pi over 2. Go down negative pi over 2. Bless you. Pi over 4 smack center for all of them. Okay. So I also need to label 1. How is 1 related to the scaling? How far out do I go for 1?
It's about like 1/3 less than the pi over 4 mark.
Okay.
Right? No, pi over 2 mark.
1/3 less than. I mean 2/3 from 0. Is that the same way? Yeah. 2/3. So 2/3 ish. Okay. And it's eyeballing it. So it's not going to be perfect, but as long as you put it in between those. Okay. So just like the original, we're going to start with the asymptotes. Asymptotes are both going to be at when x is at pi over 2 and a negative pi over 2. Tangent at 0 is 0. Tangent at pi over 4 is 1. So go up 1, just like what we did. And then tangent of a negative pi over 4 is now a -1. So here's a curvature for y equals tangent of x restricted. So in the blue, y equals tangent of x. Okay, restrictions. I'm going to use a different color for inverse. Now the inverse is really important because I would later have to use a tangent inverse to define cotangent inverse. So make sure we graph it correctly. I'm going to give you guys a second to kind of finish up that drawing. Do I have to do any math to graph an inverse? No. Can I switch the asymptotes right away? Yeah. They're currently vertical, so when I switch them out, they will be horizontal. I'm using a different color just because it's easier for you to see later if you're listening to this again. Okay. Then the points. Give me one of the points.
0, 0.
0, 0. Nice. Next.
-1, -pi over 4.
-1, negative pi over 4 sounds like a good dot. One more. 1 positive pi over 4? Yeah. Curvature. How should I curve this? Hugging the x or y? Does it go like this? Like that? No. Which way is it going? The other way. Okay. Sorry, I erased some stuff. Okay. I was not supposed to be erasing that green stuff. Okay, so go this way. Make sure your curvature is right. So there you go. Now if I go in and draw a line called y equals x, do you think it might be symmetrical? Maybe, maybe not. Yeah, hopefully, right? Obviously hand drawn is never perfect, but if we use a graphing utility, it should be a little bit better. Okay, example 1, example 2, that's all we're doing today. Do we know how to use a calculator? Example 1, use a calculator. All right, punch out, round to 2 decimal places. Guys, make sure you have the inverse curve graphed out correctly, okay? Otherwise, when we go to tangent, cotangent inverse, if you don't have it on there, you're going to be really confused why we do cotangent inverse, so make sure that's graphed out correctly. Example 1, use a calculator to find the value of each expression down to 2 decimal places. First, degrees or radians. That is always the question, okay? For these, if you don't see any bubbles in it, I would like for you to get your mode on and make sure it's in radians. Okay? All right, with radians on, you and your team, calculate the answer. I'm just going to randomly call us. So please check the answer with your team.
Go to mode.
Is your example 1 done? On all of them? Oh. Yep. That's okay. Yeah, find the answer to all of example 1. A, B, and cat.
But these are all radians?
Oh, I forgot the
Yeah, they are radians.
I can have all formats as long as they are logical equation solver. That's all. Do we need 2?
All the ones without radians.
Okay, here we go. All right, class, here we go. A, what's the final answer? Like that? Okay. B, what's the answer? 1.45. C. Okay, any questions on how to use a calculator? These buttons, are they already on your calculator? Yeah, not much to do. Okay, last example of today. The difference in directions is find the exact value. Calc or non-calc?
No count.
No calc at all. Okay. Unit circle is right. Let's see how much we remember. Let's look at the functions first. Look at it. Are these inverse functions or regular functions? Inverse. Restrictions or non-restriction? Restriction. Okay. Always. Inverse functions are always restricted. Here's the reason why. With inverse function, you're restricted to quads. It's either 1 and 4 or 1 and 2. The reason they are restricted to 2 different quadrants because you either have a positive answer or you have a negative answer. You can't have multiple positive and negative.
But for the non-inverses, you can do any.
Oh yeah, non-inverses, there's so many different answers.
Okay.
But these are inverse, so here we go. Sine inverse, restricted to what 2 quadrants? Beautiful, 1 and 4. It's sine inverse of 1, so you know the answer is positive, so it has to come from which quadrant? Uno. So it's going to be from here all the way to here, right? All right, now give me the answer. Yeah, in radians. Pi over 2. Would you agree with that? Okay. Or you do this. You go, it should be some angle, right? When you compose sine to both sides, so 1 equals sine of this angle. Keep in mind that restricted. So that angle has to be pi over 2. Okay. So you do need to know your unit circle well. That's why your teacher made such a big fuss last year. All right, sine inverse again. It's positive half again. It's positive. So what quadrant do you think the answer is going to come from? Uno again. Well, now tell me the angle in radians.
Pi over 6.
You guys are good. Pi over 6?
She's good.
Can we be able to spit out angles like that? Okay, so it is pi over 6. All right, last one. It's a little bit more difficult. Cosine inverse. What 2 quadrants is cosine inverse restricted to? 1 all the way to 2. It is negative, so you know the answer has to come from dos. Now, what angle? 3 pi over 4. All right. On the bottom.
The answer is positive.
Oh yeah, is the answer positive? Yeah. Yes, because remember, cosine was restricted from 0 all the way to pi. Is the angle at all negative here? No, so that's why your answer here is positive. Good question. Ooh, D for dog. What's the answer?
Pi over 2.
You guys agree? Uh-huh. All right, E for excellent. It's a little bit more difficult. Okay, tangent inverse restricted to what 2 quads? 1. Very good. Not inclusive at pi over 2. And 4. Not inclusive negative pi over 2. It is positive, so the answer has to come from the first. Okay. Now which angle?
6.
All right, I'm going to draw out your 30, 60, 90s just so we are completely sure. Okay. Opposite of 30 is 1, opposite of 60 is rod 3, hypotenuse is 2. So which one will give me 1 over rod 3? Which angle? 30, right? Because it is opposite over adjacent is tangent. So it's pi over 6. Last one. What quadrant is that in? 1, because it's positive 1. Okay. What angle? Pi over 4. And that's a wrap.